Today we are going to learn a very easy chapter called mathematical reasoning. This is basically the chapter deals with the logical part of mathematics, or say many of you know that you have Boolean algebra. So this is one of the part of Boolean algebra. So this is how Boolean algebra is applied into reasoning. Now this chapter, at first we are going to introduce certain definitions and terms. So mathematical reasoning, the first term that we are going to understand is called a statement. A declarative or assertive sentence is said to be a statement or proposition if it is either true or false, but not both. So we can understand that as if it has to be a mathematical statement, it has to be declarative or assertive. The meaning of that is that you cannot say something like bring some water, or alas, what a great loss. So this kind of statements are not mathematical statements, and it has to be either true or false. So there can be two things, either true or false, but not both. It cannot be both. Examples are every set is a finite set, which is a false statement because there are infinite sets. But you have to understand that this is a mathematical statement. So when we talk about the truth or false, we talk about the truth value of the sentence. Generally, a sentence is denoted by either P or Q, like that. A statement is either denoted by P, Q, R, like that. Now, the sun is a star. So this is also an example of a true statement. A statement which is both true and false simultaneously is often called a paradox. Okay, like tomorrow is a Sunday. It can be true when it is today is Saturday, but when today is Tuesday, it's not true. So this is called a paradox. Mathematics is very tough. Yes, for many of us, mathematics is very tough. But for many of the student, it can happen that mathematics is very easy. So this is relative. This can be either true or false. So this is called either a paradox. Okay, so this is not a mathematical statement. Okay. The next concept is negation of a statement. We understand that negation means which is not that, okay, which is the opposite of that statement. To get the negation of any statement, we may write before the statement three things can be written. It is false that, it is not the case that, and if possible by inserting the word not suitably. So very easy concept. Please note down the symbol of the negation of statement, which is not P. So an example is given here. The integer 4 is greater than the integer 6. So if you have to write down the negation of a statement, you have to write either you can say the integer 4 is not greater than the integer 6, or you can write it is false that the integer 4 is greater than the integer 6, or you can write it is not true that the integer 4 is greater than the integer 6. So any of them is an appropriate negation of a statement. Again, I tell you, please note down the negation of P. Now when we talk about that, we will talk about a particular thing here called the truth table. Okay, so in truth table, if I make a truth table of a statement P, which is true or false, it can be either true or false, then negation of P is very simply false or true. So true becomes false and false becomes true. A very easy concept to understand. Okay, now the next term that is associated with is compound statement. Now from here we will try to understand. Okay, so there is a simple statement that you understand. What is a simple statement? A simple statement is which is not made up of one or two parts. Okay, so there is no connectives between them. Okay, so which cannot be broken into more simple parts. So what is a compound statement? A combination two or more simple statement is called a compound statement. The examples are, there are four connectives for a compound statement. It's very important to understand the connectives. The connectives are and, or, if then, and if and only if. The symbols are very important. You see the symbol of and is kind of like an a without the middle portion of it, so it's a very easy way to remember this. Is it looks like an a, so it's and. Okay, and it is called conjunction. It is called conjunction. Or it is just the opposite symbol of and, it is called disjunction. If then, it's called the conditional statement. If something happens, then something will happen. The symbol is one arrow. And if and only, this is called biconditional statement. So both ways it is true. So the symbol is like a double-ended arrow. Now, in this regard, I would like to note that this and this chapter is basically many things are from set. So you have to understand that this and is nothing but intersection, and or is nothing but union. Okay, so many times you can apply the concept of set here to understand this. Okay, now the major of the important thing that you have to understand is the truth table of all these connectives. Okay, so now if you first try to understand the concept of the truth table, that is, when let us say there are two statements P and Q, what combinations it can have, what combinations it can have. You can have Q either true or false, or true or false. Why this is the case is because you need to write like this: the truth values of P are T, T, F and F. So all the combinations are satisfied here: T, 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 F, F, T, F, F. So how am I writing? T, F, T, F, one true, one false. Then two true, two false. Okay, and similarly if there comes an R, then we have to write 8 of these symbolizations. So TF, 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 TTFF, TTFF, and then 4 T's and 4 F's. So please do remember, always we do have to follow this. Okay, so first we will try to understand the connective, which is and again I emphasize, this is nothing but simply the intersection. So we have seen that. So an example is that the earth is almost round and the grass is green. So it's quite evident that you see there are two parts of this. Okay, the first part is the earth is almost round, and the second part is that the grass is green. Both the statements are true. So this is, let us say, P, this is Q. So both the statements are true. So of course the whole statement must be true. But in the connective and, if any of the statement is false, then the statement is false. If any of the statement is false, then the statement is false, because of course both has to be true. If both is false, of course the statement is false. So the truth table is like this. So truth is truth, truth false is false, false truth is false, and false is false. So you have to remember, if any one of them is false, so it is totally false. So that is connective and. Connective or. 98 is a multiple of 6 or 8. 98 is a multiple of 6 or 8. In this case, if both are true, of course it will be true, right? If any one of them is true, then it has to be true. So either 6 or 8, any one of them is true, then the statement is true. But if both of them are false, then it is only false. Okay, so in the case of connective, how do we remember? It's like, if any one of them is true, then the or is true. Then comes if then, the implication statement, very important. So one example might be, if ABC is a triangle, then BC plus CA is greater than AB. So this is an if then. Now in this case, what happens is, if both the statements, like if you understand here, there are two statements. ABC is a triangle, this is one statement P, and BC plus CA greater than AB, this is another statement Q. If both of them is true, fine, true. If the first one is true and the second one is false, then it is of course false. And if the first one is false and the second one is true, then it has to be true. If something is false and then something becomes true, it becomes true. If both of them are false, of course it will be true. If both of them are false, then it has to be true. The if then statement must be true. So how to remember this? We can remember like this, that there were two persons, right? So one is here, one is here. So the person who always tells truth is telling truth, fine, we are also okay with that. Okay, if a person who was telling lie, false, is now telling truth, fine, very good, he's a very good boy. Okay, and if the person who was already telling false, already telling lies, also telling now lie, no change is happening, okay fine, no change is happening. But if a truthful person becomes a deceitful person, then it is of course difficult. So actually TF only becomes false, otherwise everything is true. Please do remember this, this is very important. Okay, then comes the biconditional statement. For biconditional statement, we have an example must be a quadrilateral is a parallelogram if and only if its diagonal bisect each other. So it's both ways true. So quadrilateral will become a parallelogram if its diagonals bisect each other, and for a quadrilateral whose diagonals bisect each other, it must be a parallelogram. So in this case, the truth table is truth, truth of course becomes truth, truth false is false, false truth is false, but false false is true. Both the sides are false, so it has to be true. Okay, so these are the connectives, if and only if, and all the other connectives. Here, what is the takeaway? You need to understand that you need to remember the truth tables. You need to remember the truth tables. Okay, so that is what is important here. There are two quantifiers. Okay, there are two quantifiers in here. One quantifier is called there exists, and the symbol is mentioned here, so it's an opposite of an e. So the quantifier there exists a natural number. Whenever we say like that in mathematics, right, there exists a natural number such that x belongs to n, where 3x plus 5 is equal to, let us say, what, 17. Okay, so like that. And for every, so that is an universal quantifier. So what is an universal quantifier? For an universal quantifier, it means that like the symbol is this. So for every x belonging to real number, there exists, let us say, 3x square plus 5x equal to something. So like that, it is these two are called quantifier. Now there are various terms associated with how we can write down one statement. This is basically used for proving purpose. Okay, these are basically used for proving purpose. So I'll give one or two examples of those. So there are three things called contrapositive, converse, and inverse. So contrapositive of a statement, contrapositive of a statement. So let us say you have a statement P implies Q. So all these three you have to understand is for conditional statement, if then statement, right? So if you have P implies to Q, if you have P implies to Q, then negation Q implies negation P is called a contrapositive statement, is called a contrapositive statement. Negation Q implies negation P. I am giving one example. Let us say you have let us say you have uh, if a plus 3 is 8, then a is 5. So this is an implies to statement. To write down the contrapositive, you have to understand this is your P, this is your Q. So what you have to write? You have to write, so if the negation of a equal to 5 is a not equal to 5, if a is not equal to 5, then a plus 3 is not equal to 8. So first the negation of this one will come, then it implies to negation of this. This is called contrapositive, very important. Converse, P implies to Q, Q implies to P. If A equal to 5, then A plus 3 equal to 8. Very simple. Inverse, P implies to Q implies not P implies to not Q. If A plus 3 is not equal to 8, then A is not equal to 5. As simple as that. As simple as that. Okay. So these are the examples of contrapositive, converse, and inverse. Contrapositive, converse, and inverse. Okay. So very important concept here. So these are the methods of proving. Okay. There is another method of proving called contradiction. I would here like to remind you, you used to do this in your junior classes, that prove that root 2 is an irrational number, right? Root 2 is an irrational number. There, first you assume that root 2 is a rational number, and then at the last you proved it cannot be possible. So there is a contradiction somewhere. So that proof is called contradictory proof, contradiction, proof by contradiction. So there are various kinds of proofs. So you can use by contrapositive, converse, inverse, or contradiction. Okay. Now, there are some laws associated with mathematical reasoning, with these statements. Now, there are various laws, and actually all the laws are the laws of the set. The properties that we have are all the laws are of the properties of the set. Now, there are many properties, like it can be, I'm writing down some properties. So if I talk about the properties, remember all the properties are of set. So whatever properties the set had, you have here. Like you can have P or Q or R, is basically wherever you give the bracket, it doesn't matter. What is it called? It is called the associative law, isn't it so? It is the associative law. Then you can have, if P is P and Q is equal to Q and P. This is also true for and also. So this is also true for or. So I'm just writing down one or two example. This is called commutative, right? Another law which is called the distributive law. Sometimes it is very important. Okay, so distributive law is, let's say P and Q or R is P and Q and or P and R. I hope you understand here. When we open the bracket, this two comes, and in between these two comes. You can write like this: P and Q, this, it will become, all these are set laws. Okay, sorry, should be R. Okay, so this is called the distributive law. Okay, now let's go back to the De Morgan's law, very important. Okay, negation of P and Q. This is basically what the De Morgan's law in set was: A intersection A complement intersection B complement is A union B whole complement, and A complement union B complement is A intersection B whole complement. Correct? This is the law. Simple. Negation of P and Q is implying to negation P or negation Q. Negation of P or Q, negation P and negation Q. You can prove it by simple use of truth table. I think this should be a homework to prove both the side by truth table. Okay. So this is very important. Okay. Another thing which is very important is, let me write that down, is it's about a conditional statement, and that is P implies Q implies to negation of P or Q. This is very important. Okay. So how this comes? Let us do prove it by truth table. Okay. So if I write P Q, so always you know how to write. I have taught you TF TF TT FF. Now let us write P implies Q. So I've talked about that. Let us revise the concept. True, true. Okay, no problem. True, false, we have a problem. A truthful person becoming a deceitful person. False, true, no problem. True, false, false, no problem. Now negation of P. Truth becomes false, false, truth, truth. Negation of P. This is OR Q. When we do OR, what we have, if there are two false, then only it is false. So false, true, true, false, 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 true, 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 and true, false, true. I hope you understand that I am doing this or this. So you can understand this column and this column are same. So P implies to Q in terms of OR is negation P or Q. Is negation P or Q. Next, negation of a conditional statement. Again, very important. Negation of P implies Q is P and not Q. P and negation of Q. Prove it by truth table. It will be a good practice to prove with this by truth table in your home. Negation of biconditional statement. Negation of P if and only if Q is P and not Q or Q and not P. So this is negation of biconditional statement. Prove this by truth table again. Okay. Two concepts which is very important. One is called tautology. Tautology is denoted by T. It is called universal truth. So all of the statements are truth. All the condition, whichever you put, you get T. So when we have to prove something is tautology, in the last column of the truth table, it will come all the T's, all the truths. And fallacy or contradiction, it is written F. Fallacy or contradiction, C is universal lie. That is all of them are F, 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 F. So these are the basic terms associated with the chapter mathematical reasoning. Now let us look into some of the sums. So here we have all the MCQs. Okay. So this will illustrate our concepts, what we have learned. The contrapositive, see, the contrapositive of the statement, if I reach the station in time, then I will catch the train. The contrapositive of the statement, if I reach the station in time, then I will catch the train. Now you have to remember what is contrapositive. So this is P, this is Q. So this is an implication statement. P implies Q. The contrapositive is negation of P implies negation of P. Sorry, negation of Q implies negation of P. Q is I will catch the train. So of course I will not catch the train. So let us see. I will catch the train. I do not reach the station. I do not reach the station. I will not catch the train. See here, only one option has I will not catch the train, then I do not reach the station in time. So this number 4 is the contrapositive of this statement. I hope it is clear. Remember this, P implies to Q is not Q implies not P. Next question. Which of the following is a tautology? Now, tautology is universal truth. Universal truth. This kind of sums can be done in two ways. One, by using the truth table, and two, by using properties. Okay, so let us do both. Okay, so for the first one, let us see whether we can do this. P Q. So true, false, true, false, 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 or truth, truth, false, false. First, what we have, not P. Calculate not P or negation of P. False, false, true, true. Then with what we have, P here, P or Q. So in P or Q, remember what we have, if there is one truth, it will always be truth. So only one false. Then we have negation of P and P or Q. So we have negation of P and this. So these two columns, right? So when you have these two columns, you remember for AND truth table, if you see the truth table, if you see the truth table of AND, you will understand if there is only one truth, only one false, it will be false. So only one case it becomes true, that is true, and true is true. So everything else, this is false, this is false, this is true, this is false. Okay, so only two true is true. Then what we have, so we have this and then it implies to Q, right? So then it implies to Q. So when it implies to Q, so this and this, so there was a false person, it becomes a truthful person, so no problem. So he becomes a truthful person. False person with no problem, false person remaining false person, so truth person becoming truth person, always very good. False person becoming false person, remaining false person, so truth. So you see, this is the tautology, all are truth, all are truth. So this is called a tautology. Here we understand there was only one option correct, so the number one would be correct. But in the other cases, you have to check whether this is tautology or not. That may be done by you. This can be done by properties also. Okay, let's try that. You have by property, you have this and P or Q implies to Q. See, first we can apply the distributive law. So if I apply the distributive law, not P, this will become this, that is and P, or not P and Q implies Q. Now see this one. This is nothing but A complement intersection A. This is nothing but A complement intersection A. We all know that is a null set. Here null implies fallacy. C. Okay, contradiction. Okay, fallacy or contradiction. So this is C, or P or Q this. Try to understand, this is very simple, that this is contradiction, that means null set. If you do union with any null set, this is union, right? Or this is union, you get that number itself, there's no change. Okay, so null set union with A is nothing but A. So therefore this is nothing but, if you calculate this is nothing but this. Now what to do? Now you see, I taught you a formula, a property of implication, that P implies Q is not P or Q. It's not P or Q. So P implies Q, this is your new P implies Q, is not P and then what we had, not P or Q. So this is the thing. Okay, not P or Q, isn't it so? So what we can say here, that this is nothing but, now we are just opening up the brackets. So it would be P, right? Just opening up the brackets. So what we have here is basically you have, this is A complement union A. That is the universal set. That is the universal set U. And here universal set means tautology T. You can write small t. So tautology T. So this is P and tautology T, and with universal set, whatever you do, you get tautology. So this is simply set. You can do by Boolean, you can do by property, it's your wish. Okay, let's go to the next question. So here, one thing to understand while doing the property, remember it's set. That's it. And then it will come. Then it will come always. Okay, next question. Let P, Q, and R be three statements such that the truth value of P and Q implies not Q or R is F. So this truth value of this thing is false when an implies to statement becomes false. Only thing is that the truth and false. Truth implies to false implies false. So therefore this will be truth and this will be false. Now and statement is true when it becomes an and statement true. The and statement is only true when both of them are true, right? So we can understand P is true, Q is true. You see the truth table, you will understand. And statement true, 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 false, true, true, false, 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 true, false, 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 false. So now there is only one option where these two becomes true. So and it implies and the and becomes true. So P is true and Q is also true. Now this is false. This statement is false, right? Now we have already proved Q is true. So not Q must be false. So false and R is false. So what about R? False or R is false. We understand that for or everything always becomes true excepting when false becomes false. So therefore R is false. So therefore we have the option 1, truth, truth, F. Truth, truth, and F. Next question is a question about tautology and fallacy. So two things are given, S1 and S2 is given. You have to show that whether S1 is a tautology or S2 is a fallacy or both are correct. So it's very simple. Let us draw the truth table. So P, Q, T, F, T, F, T, T, F, F. What we have, Q or P. So Q or P, truth, 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 false, false, truth, truth, false, false, false. And then we have P biconditional, not Q, right? So would have been better if I would have calculated not Q, no problem. Not Q, I am writing it here. Not Q is false, true, false, true. So look, non-conditional statement. So let's go back and try to understand what is biconditional statement. True, 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 false, false, true. Otherwise it's false. So true, true. So P, true, false, false, true, 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 false, false, true, false, true, false. And then you have this column implies to this column, right? So I'm writing column 1 implies to column 2. So let us say this is 1, this is 2. That's what we want. So implies to column 2. Implies truth becomes false. Very problematic. False. Truth, truth, truth. No problem. Truth, truth, truth. False, false, truth. You see, this is not a tautology because this is not coming. It has to be, the column has to be all true. So it has to be tautology. Okay, it has to be tautology. Okay, so otherwise it's not. So this is not tautology. What about the second one? So you have P, you have Q, or you can calculate it here also, no problem in that. Let us do it here. So we are already through with, we have already calculated this, and let us calculate this. Not P, biconditional Q. Let's calculate not P. False, false, true, true. Not P, biconditional Q. This one. So false, true, false, 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 true, true, false, false, true, false, false. No problem. And not Q and this one. So not Q, this one, this and this one. And means if it has to be true, if both are true, otherwise it's false. So false, 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 true, 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 false, 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 true, false, false. See here, this is not a fallacy or a contradiction because of this T. It has to be all false. I hope you have understood. So this is all the 4 would have been false. Then it would have been a contradiction. So here both S and S1 and S2 are not correct. Both S1 and S2 are not correct. Next question. The negation of the Boolean expression. So the negation of the Boolean expression X biconditional negation Y. See here, it's a very basic question from the theory. Why? This is about this question. Negation of bicondition. Negation of P implies Q is P implies C, this one. This one. So P and negation Q. Let's go back. So this should be P and negation this. So why? Negation of negation, right? You understand? Here negation of negation Y, and then or Q and not P, or Q and not P. So X, Y, or negation Y, negation P. See, is there any option? I guess this one. This one is the option, right? Sorry, I have written P here. This should be X. Okay, this should be X. Okay, so very basic question from the basic theoretical part. Let's look into another question. Okay, again, a very simple question. If I drew the truth table, if I do the truth table, I hope it will come. So what is equivalent to? It's a contradiction, it's a tautology, it's equivalent to. So we need to see to that. Okay, so let us draw the truth table P and Q. So first is let us calculate Q implies to P. Say Q implies to P. Truth, 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 false, truth. So good. Okay, no problem. Truth, false, problematic, false, false, truth. Then P implies Q implies P. Okay, so P implies. So truth, 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 no problem. Truth, 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 false, false, truth, false, truth, truth. So no problem, right? And now we have P or Q. So see, P or Q. P or Q, it's always that it has to be always true until and unless both are false. So true, 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 false. Then we have P implies this. So if P implies, so truth, 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 see, truth, 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 false, truth, 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 truth. So now this column implies this column. It has to be all truth, right? So this is a tautology. Okay, this is a tautology. So this is the chapter. Nothing much, very easy chapter. What kind of questions come? In generally in your school questions, generally writing down the negation of a statement, converse of a statement, contradiction of a statement, or contrapositive of a statement, or proving some property by truth table, and whether saying whether it's tautology, whether it's a contradiction, and property based sums. And you can understand what kind of questions comes in JEE Mains. In mains, always this kind of question comes where we have to find out whether this is a tautology or a contradiction, or sometimes contrapositive, using property or using Boolean algebra, that is using the basic concepts of truth table. So this is a chapter, very simple chapter. Hope this video helps.